Hello there, and Happy New Year. This is Ms. Nakayama, and I'm really sorry that I'm not with y'all again. I will be back next week, so make sure you look at your calendar in Schoology, but your first quiz is on Tuesday. I will be back on Monday to make sure I'm there to answer any kind of questions. But remember, Miss Matthias is there in the morning, and you got math help during AO if you can't get your questions answered by anybody in class. So let's get started. Today's lesson is 6.1, perpendicular and angle bisectors. Okay, you talked about bisectors before. We've actually talked about perpendicular bisectors. It is a line that is perpendicular to a segment at its midpoint. Now, we define it as a line, but remember, it can also be a segment, a ray, or a plane. Okay, here's a picture. You probably already have it on your note sheet. Okay, CP is a perpendicular bisector of segment AB because it's perpendicular by that little symbol there. And these two tick marks tell us that those two segments are congruent, and therefore it bisects the segment. Okay, next we have the angle bisector, and that is a ray that divides an angle into two congruent adjacent angles. And here's a picture that, I cut off on yours. Ray AD is an angle bisector of angle BAC. We know that angle BAD is congruent to angle DAB. Also keep in mind, a point is equidistant from two figures when it is the same distance from the figure. Keep in mind that when we talk about distance from a figure, that's always represented by the shortest distance, which is perpendicular from one point to the line, or however you wish to look at it. And you'll see in our pictures why the perpendicular comes up so often. So the first thing we have is something called the perpendicular bisector theorem. Okay, tells you if a point lies on a perpendicular bisector of a segment. So we know that P is on this perpendicular bisector. We know it's perpendicular. We know it bisects. Then that means that P is equidistant from the endpoints of the segment. So mathematically speaking, if PM is perpendicular to AB segments, then M and MA is equal to MB, then we know that PA has to be equal to PB, as marked in this figure. That's our perpendicular bisector. The converse of that would say, if I know that PA is equal to PB, then I know that P has to be on the perpendicular bisector of segment AB. So that means that segment PM is perpendicular to segment AB, and I would know that AM is equal to MB. Okay, that's our perpendicular bisector. Then we have our angle bisector theorem. That tells us if a point, in this case S, lies on a perpendicular on the angle bisector, then we know that it's going to be equidistant. So in this case, when you look at it mathematically, it's on the bisector. QS bisects angle PQR, but they have to tell you it's perpendicular because that's what represents the distance from S to the sides of the angle. And so in the next picture, we can see that PS is equal to SR. That's how you write that they're equidistant. But equidistant means they have to be perpendicular. You can't just measure any distance S. S has to be perpendicular. However you're measuring S to the side of the angle, you have to have that perpendicular symbol. Okay, and the converse of that would tell you, if I know that PS is equal to SP, and of course it has to be perpendicular, then I know that QS is the angle bisector of PQR. All right? Now, let's go see what we can do with those. So first off, find each measure. So I'm looking at this picture and I can see that DB is a perpendicular bisector of AC. So DA has to be congruent or equal to DC, and therefore CD is equal to 27. Number 2, I have a figure SQ. I'm told SQ, and I know that SP is equal to SR. That means that PQ has to be equal to QR, and they're asking me for the distance of PR, and so that has to be 10. Because it's equidistant from the endpoints, and then it lies on the perpendicular bisector. Okay, we're looking for GH. This time, again, I have a perpendicular bisector. It's perpendicular. These two segments are equal. So it's on the perpendicular bisector. That means that GH has to equal HE. So I set up my equation. 2x is equal to 3x minus 8. I'm going to subtract x, and then I'm going to divide by -1, and I'm going to get x is equal to 8, which in turn tells me that GH equals 3 times whatever x is minus 8. X is 8, so GH is equal to 16. Okay? Number 4, line ZX is the perpendicular bisector of WY, and WZ, which is right here, is 4n minus 13. YZ is n plus 17. Find YZ. So if they tell me this is on the perpendicular bisector, if it's on the perpendicular bisector, then I know that it's equidistant from the endpoints. So I'm going to set up my equation and say that 4n minus 13 equals n plus 17. I'm going to subtract n and add 13. Subtracting n gives me 3n, add 13 gives me 30, and then divide by 3. So n equals 10, and that's going to be taken over to give me yz. And to find yz, I'm going to plug in 10 for n, so yz is equal to 27. All right, look at number 5. Is there enough information given in the diagram to conclude that point L lies on the perpendicular bisector of KM? So point L, okay? Does it lie on the perpendicular bisector? Well, we know it's the bisector, but we're not told anywhere that it's perpendicular. We don't know that NM is equal to KN, so we do not know that it's on the perpendicular bisector. Mainly, we would need to know that NL is perpendicular to KM. Okay, some more pictures. All right, down here, I'm looking at, it appears that AC is perpendicular to DE, and it bisects DE. So AC is the perpendicular bisector, which means that AC and AB have to be the same, 15, and BC and DC have to be the same. So it's not that difficult if you know the theorem. So you really just need to practice and think through these things. So find the value of X and MN. So MO is a perpendicular bisector of NP, and if it is, then M is equidistant from N and P, which makes MN equal to MP. So to set up my equation, I'm going to say that 6x minus 1 equals 3x minus 8. I'm going to subtract 3x and add 1, so 3x equals 9. Divide by 3, x equals 3. That's one part of what we had to do. Then we have to go find out what MN is, and MN is 6 times whatever x is minus 1. X is 3, so MN is 17. All right, number 8. Find the length of RS. So I can tell that VS or US, however you wish to look at that line, is the perpendicular bisector of RT. So any point on that line is equidistant from R and T. So RS is equal to RT. So 3x plus 11 equals 7x plus 3. I'm going to subtract 3x and subtract 3. So 8 is going to equal 4x. And then I'm going to divide by 4. So x equals 2. And then I'm going to take that and plug it back into my expression for RS that says 3 times whatever x is plus 11. X is 2. So RS is 17. All right. 9. Find the measure of angle ABC. So if I have BD, I know that AD is perpendicular and DC is perpendicular, and the distances are the same, the lengths are the same. So that means that D is equidistant from the sides of the angle, and therefore it bisects the angle. So that means that this angle inside here has to be 56. So what is the measure of angle ABC? It is 112, because that's 56 times 2. All right, number 10. This time we're told that KM is an angle bisector because we have these little marks in here telling us that those two angles are congruent. Therefore, 4x has to equal 2x plus 12 because they are equidistant. Subtract 2x and divide by 2. So x equals 6, but they're asking me to find JM, and JM is 4 times whatever I have in parentheses, or whatever x is, and x is 6, so JM is 24. All right, number 11. Let's see, BD, they tell me that BD bisects angle ABC. And if it bisects the angle, then I know that the distance from A to D is equal to the distance from D to C. So 3z plus 7 has to equal 2z plus 11. Subtract 2z and subtract 7. Z equals 4. What am I looking for? I'm looking for CD. And CD says 2 times whatever is Z equals plus 11. Z is 4. So CD equals 19. All right. 4 more problems. So in number 12, it says find X and OM and OP. So I'm looking at my picture. I see these marks down here telling me that those two angles are congruent. So LO is the angle bisector of angle LMLP. That means these two distances are equal to each other. So 6x equals 3x plus 12. Subtract 3x. 3x equals 12. And divide by 3. And x equals 4. Now I have to go find OM. And OM is... What's OM? OM is 6 times whatever I have in parentheses. And my parentheses is 4. So keep in mind that's also OP. So I know that OM equals 24, which also is OP. Number 13, find angle JKM. So angle JKM is an angle bisector. KM. Ray KM is the angle bisector of JKL. And JKM has to be the same as MKL. So it's just 38 degrees. All right. A parachutist lands in a triangular field at point P and then walks to a road. Will he have to walk further to Wells Road or to Turner Road? Well, P, you see by these marks up here, P is on the angle bisector. And if it's on the angle bisector, then the distance, which the shortest distance is that distance, and it would be perpendicular. So the distance from P to either side of the angles are the same. So period. Both distances are the same because that lies on the angle bisector. All right, last but not least, this is one that starts off your homework. Write an equation of the perpendicular bisector of the segment with endpoints 5, -1 and -11, 3. So this is a 3-step process. Number 1, you want to go find the midpoint. So the midpoint, remember, is I'm going to add up the x's and add up the y's. Add up the x's and divide by 2. Add up the y's and divide by 2. So I have 5 plus -11 divided by 2. And I'm going to have -1 plus 3 divided by 2. And that becomes -3, 1. So I have the point that my line is going to contain. Next, I need to go find the slope. So I got to find the slope of DE. And the slope of DE, remember, it's the change in x over the change in y. That was too much. It's not the change in x, it's change in y over change in x. So I'm going to subtract my y's. 3 minus -11 over, 3 minus -1. That's my y's. That's these guys. Change in y over the change in x. So 3 minus -1 over -11 minus 5. That gives me 4 over -16, which is -1/4. I need the perpendicular bisector, so that means that I've got to flip it and negate it. Get the negative reciprocal of -1/4, and that's +4. And now I'm going to go write the equation of my line, which is point slope form. Y minus the y coordinate equals the slope times x minus the x coordinate. So it does not matter which one I chose. Pause for 1 second. So we're writing the equation of the line with this point and this slope using the point slope form. Y minus y sub 1 equals m times x minus x sub 1. So that gives me y minus my y coordinate, which is 1, times my slope, which is 4, and x minus my x coordinate, which is negative 3. So when you simplify that, that's going to give you y minus 1 equals 4 times x plus 3. That is an acceptable way to leave it, even in Delta Math. But if you have to go to point slope form, if that's what you wish to do, then you would distribute y minus 1 equals 4x plus 12, and then bring the 1 over, and that's y equals 4x plus 13. Delta Math will accept either one of those. This one's a lot less work, easier to do, and if you can do it, save yourself some time. So that sums up our perpendicular and angle bisectors. Thank you so much for watching, and y'all have a great day.